Hopefully it shows up. Alright, we're going to go ahead and get started, alright? You have your warm-up here on the board. We have paper at each desk. Go ahead and take a sheet of paper. There's circular objects that you can use, or you can use a compass. We're just going to go ahead and we're going to draw circles on our paper as a warm-up, alright? These are going to be used later on in the lesson, so they're very important. We have these people on the left hand.
It doesn't matter what we put it.
Nope, you create a circle of your sizing, whatever you want to do. Just make sure it's a good circle. While you're making these, I'm going to go ahead and get you each a piece of string. You're going to use this later on as well.
Randomly wander the classroom to make sure everybody working. I want to make sure that you
Thank you.
You're welcome, sir.
So right now, I've only got Patty.
Pretty much like Walmart. Anywhere that. So
Thank you.
Here, can I have one too?
Yep. There you go.
Alright, when you've drawn your circle, let me see a thumbs up so I know who's ready. Good, Quincy? Yes.
I might have to
Take it out.
sit in the car.
I kind of love to hold through it.
You get a
Because I have a substitute over there.
I poked the hole through mine.
Perfect, that's your midpoint.
Oh, okay.
If you have a hole in your paper, that's perfectly fine because that's going to be your midpoint, alright? John, you ready? Halfway? This is your midpoint here? Alright. If you want to put that a little bit bigger with your pencil, that would be probably beneficial. I'm going to be handing out your flip books that we've been working on this week. These all fancy color coding. That's Joel, right? Oh, that's John.
No, that's
There you go.
Can I do another one?
This is you, Joel. Who's orange?
This is down here.
Is yours book?
I'm sorry.
I made one up for you
Right, can I have
last night since I
another
know you didn't have one.
Thank you, sir.
Gene, do you have your flip book or do you need one?
I already have one.
Paper.
We'll work on the freshman. Alright. Today we have our LEQs. Our LEQs how's the circumference formula of a circle derived and how's the area formula of a circle derived. We've been working lately with area formulas for different shapes, and we haven't really talked too much about perimeter, right? Because we know when we have perimeter we just add up all the sides. But with a circle, what's unique about a circle? There's not really any legitimate sides. It's just one long line that goes around in a circle, right? So we really want to explore this circumference today because it's really unique and it only takes place in circles, right? So the goals are to understand how we come up with the circumference and area formulas, and then to be able to use these formulas when given a certain circle with maybe an area or a diameter, all right? So, I gave you all each a piece of string, right? If I were to say the word radius, do we know what the radius means?
No.
No.
I hear a little bit of confusion. So, I have sort of like a bodily device that's going to help you to remember these. So, everyone go ahead and stand up, push your chairs up. And then take a couple of steps back like you're against the wall, because you're going to need some space here, okay? Looking up radius? Alright. While Cody looks up radius, here's what we're going to do. Alright? Imagine that you're standing out in the middle of the field, okay? And there's a bird that's flying all around us. If it's looking down on us right now, what does it see?
An ant.
An ant?
Dot.
Dot? We're going to look like a bunch of dots to a bird, right?
Yeah.
So if we put our hands on our head like this, we're just a circle, a dot in the middle of the field, right? Go ahead, put your hands like that. Right now we're a dot, right? If that bird looks out at us, say we're on the street corner and we're hitching a ride, right? We're hitching a ride. R for ride. Good? What's this in math? Angle? What's an R word that we're looking for that deals with circles?
Right.
Radius.
Radius. This is going to be our radius, right? We can go all... Go ahead, put your arm out. Show me your radius. Alright? And if you have this radius extended all the way, you can turn, right?
Yep.
And no matter which way you're facing, that's our radius, right? So if a bird's looking down on us, he sees a dot and a line that goes out to the edge. This is our radius. If we're desperate, we need a ride pronto. We're walking up the street. We got hands going everywhere. Hey, I need a ride. I need a ride. I need a ride. We're desperate, right? Desperate is D. What do we know that has a D in it for circles?
Depth.
Depth?
Or dimension.
I think he's close.
Distance.
Diameter.
Oh my goodness, Cody got it. Diameter, right? So now if the bird's looking down on us, he sees this dot, and he sees a line that goes from one side of the circle to the other. Diameter goes all the way across the circle, right? So I'm going to end up whacking the smartboard, but if I were to turn, I have a diameter. Careful. Oh, got it. Go ahead, put your arms out. Show me your diameters. And if you spin, no matter how you're facing, that's a diameter in a circle, right? Oh, Gene's whacking his diameter on the wall here. Alright. So, what I want you to do, here, let's see if we, no, you know what? What is it when we do this? When we're going around and we're shaping this circle, we're making a circle. What's the outside of a circle? Circumference. We're making a circumference when we do this, right? So now what I want you to do is pretend that we're back in kindergarten, all right? And it's finger painting time, right? So we're gonna.
I do miss that.
I do too. I wish we still had it. It would be wonderful if we still had finger paint time.
We'll make time for
I
that.
remember doing that.
And I was always that kid that they're like, okay, dip the tip of your finger in, and I'm like, nope, whack, right? I mean, I'm pretty sure there's a couple of us in here that did that. So we're gonna take fistfuls of paint, right? And go ahead, extend your arms, your radius, and let's paint all this right here. What are we painting?
Or DJ table.
When we come around. Yeah, it looks kind of like a DJ
The
table.
outline, circle.
If I'm painting, what am I painting? I can paint a piece of paper. I can paint the smartboard. What am I painting right now?
Object.
Air.
The air? What have we been dealing with that sounds a little bit like air?
Area.
Area.
Area, right?
Painting the
So everywhere that these arms can extend and paint inside of this circle, that's our area, right? So now everybody come back to their papers. On the squat. Now, what I want you to do, you're going to use your string, right? Everyone, put your string on your paper and show me radius. What's the radius look like? Good job, Cody.
One up there.
Radius, what's the radius? Which one? Is this radius or is this
So it'd be like just
Shut up.
Right now
Just
you're getting 2 lines. What's that when we're desperate? That's
Please be quiet. I didn't copy you.
radius.
like that.
Good job, Gene.
Well, he said
Uh-oh.
Is that good?
We have a little bit of a disagreement here. Who's right? Quincy or Jocelyn? Argue. Fight for it. Who's right?
I win. Radius is stretched out.
Radius is stretched out. So
But it's
am I
only
just
one
hitching a
hand.
ride?
It's not 2 hands.
Am I hitching a ride or am I desperate?
We're hitching a ride.
It depends.
Desperate
Hitching
is
a
what?
ride.
We're hitching a ride, right? So we're just one side of this circle.
Jocelyn.
So here we go. Your radius is only
Yes.
halfway, right?
See?
Show me diameter. Quincy got it.
Yeah, see? Uh-huh.
Diameter? Cool.
Diameter is
What do you got for diameter, Gene? Jocelyn's good. Damir's good.
Look at mine.
He's using his resources. This is math class, man. Alright, it's pretty good. Alright, now, last thing I want you to show me is circumference. Show me the circumference right
Oh,
now.
this is easy.
You want to use this way?
This is the circumference.
Good, Joel. Good job, Damir. Good job, Quincy.
No, she got it right.
Alright, you're getting it around that outside edge, right? The string is going to show a circumference that goes around the edge of the circle.
My
So-
string turned gray.
Oh, wow. You're doing area right now, man.
No, use the gray one. That's already on there. You gave me the answer.
This is going to be really cool what we find out.
My string barely fits.
Yeah? Alright. So, for you guys, for instance, right where that overlap occurs, you're going to use the marker that I gave you and put a dot right there.
Wait,
and make
what?
sure it hits both pieces of string. If you start at the beginning, that works even better because now you only have one dot to worry about, right?
Yeah.
So we want this to be real tight because we want our measurements to be accurate when we get into the next portion. So go ahead and put a pretty nice size mark right there.
You won't lose that mark later. Not know where the heck it is.
You don't want to use
Right
yellow.
where
Make
it
this
touches.
Can you see the yellow okay, Bob?
Did you put a mark on it? Put your circumference. And then once you've gotten that far, Gene, put your string around and make the circumference.
I should tie it.
Alright, got your marks. Good. Once you get to this point, just mark it. Mark it on both pieces of string, alright? Because that's going to be your starting points and your end point.
There we go.
Good job, Cody. Now mark it on both pieces where it overlaps. So, right. Where'd you start at?
Just like intercepted it.
There we go. So you want to make your mark right about there on both pieces of string, okay? Now, once you've found your circumference, you can go ahead and stretch that bad boy back out. Alright?
Yay!
And wherever your two marks are, that shows the length of your circumference, right? Now, next step. You're going to take that same piece of string, start on the edge of the circle with one of your marks, and show me the diameter again. We're going to try to see how many diameters fit into the circumference, right? So, you started there. Once you get a diameter, put another mark. So see how she's doing? You want to start on one of your pink dots, and then when you get across the whole edge there, you're going to put another dot.
In the middle?
Yeah. Let me see where you're starting. Yep. And now you would put a dot here, right? Because that's a diameter. Go ahead and do that. Yeah, you're going to stretch yours out. You already found your circumference.
Why not?
I just broke it.
Good.
You can't break it.
Yes, you can.
Alright, that's good. Now go all the way to this green dot. See how many diameters you can fit in
Was
that.
it supposed to be a different color?
No, it's fine. You can use the same color. So there's one diameter, right? But you're not quite to your circumference point. You need to see how many diameters fit into that circumference.
Could it be like this?
Yeah, so now you're just gonna, there you go, that works. And now you put another point.
Thinking that's how you do it. So, Mr.
Yes, sir.
Pretty much, so on each side we
Where's your starting point? You use one, right?
trade.
Well, you can't trade strings though, because he has a different size circle than you. So you're gonna have to trade strings.
We didn't trade straight.
Oh, you just traded one. Okay. So, where's your second? Did you start at the beginning of the string? And then go to that? And let me make this clear, because the last class made this mistake. They went to the end of the string. You just want to go to the end of your circumference. All right?
Like
So-
and oh, okay. Gotcha.
There's one.
Yo, Hannah
Now you're gonna start
Montana is my
here.
favorite movie.
Put another
It's like
dot.
this.
Yeah, you only did one. So put another dot. So that's two, right?
So Mr. Cook.
Yes, sir. There's three.
I didn't go through fully.
This one. Here's your first one.
We go.
No, no
Wait,
faster.
what else are we doing?
What's going on, John?
You keep on going
You good?
until the end of the string or the end of the mark.
So,
You fold
Somebody
it again
fill
and again.
Daddy in on what's going on.
so keep
Use
on
your
doing
card
what we're
reader.
doing is.
This guy needs some help. Yeah, I didn't go all the way through.
All right, you couldn't quite make it. How many did you fit in there, though?
Wait, we keep on going like this?
1, 2, 3.
Three and then a little bit?
Yeah.
Like that?
No!
This is your circumference, right? From this point to this point. Oh, and you already did one diameter, right? So you just shook it out.
I'm kidding.
Oh.
Alright, and see, until you get to that pink top, you put that in. How many dots did you get? And then there's that little bit in between those two, right? Right at the end there?
Put your finger to it. It
You know, you end up at the point where you rounded it.
Alright, come back to me right now.
This one right here.
Jocelyn, how many diameters fit into your circumference?
3 and a bit.
There's a little bit left at the end. Come here, what about you?
3 and a bit.
3 and a little bit? Cody, how many fit in yours?
Oh.
3 and a little bit. How does this make sense? We all have different sized circles. Jocelyn's circle is much bigger than Damir's circle, but they both got...
String, same size.
No,
No, it's
no, we have different sized strings and everything.
So, Mr.
So there's a circle.
So we each got 3 and a bit. 3 and a little bit left at the end. So go ahead and open up your flip books. I'm going to give you your circumference formula now.
It's 2
for
pi
circle.
times radius.
For circle.
For circle, yes.
That's pi.
That is pi.
3.14.
Pi is 214. Have you ever seen those books? It's like based off of medieval times, and it would tell you like math.
So here's what I want you guys to do. Talk amongst your table, right? I just put up C equals pi times D. And we just discussed Jocelyn had 3 and a little bit. Damir had 3 and a little bit of the diameters that go into the circumference. Cody had 3 and a little bit. What do we think this means when we look at this formula? Okay, talk amongst your table. What do you guys got? Jocelyn, here's some Cody.
Why are you asking me?
Because you never answer everything.
Because I'm good at math.
What is pi? So let's bring it a little bit. So every time we do measure our circles out, and we do 3 diameters going to plus that location in.
This is way
You see how this formula is doing?
This goes straight through.
It's saying that there's going to be pi amount of diameters of each circumference.
Straight through. There's no problem.
So,
You see that? I knew we doing.
Can you guys stop calling that book?
Alright, what kind of things you guys talking about over
I
here?
don't know.
Where?
So what?
They
How
asked
does
me.
it equal 3?
Equals pi.
Yeah, if I put this formula on the board, and you all 3 got the same answer, right? You guys said there's about 3 diameters plus a little bit in the circumference.
Mm-hmm.
What's pi?
What's what?
3.4.
3.1415.
So 3 and a little bit?
Oh, so every
Oh!
every circle it equals 3.
Mind blown, right?
Yeah. But how can it do it like if you got like one huge one and then you got a little one?
Alright. Good, valid question. Everyone, eyes up here, alright? I think I just blew Quincy's mind out of his head. I'm not sure what just happened, but it was like a light bulb explosion here. What he said is, all of our circles are different sizes, but somehow our diameters all went into our circumference, 3 and then a little bit. And I asked this group up here, what does pi mean? And they said 3.14. So pi equals 3.14. Can we agree that 3.14 means 3 and a little bit?
Yeah.
It's 3 and a little bit, right? So this is why pi gets put into this formula right here. Because for every circumference, for every circle, the diameter fits into that circumference pi amount of time. Alright? And Quincy's question was, what if I have a little circle and a big circle? With this little circle, here's our diameter, right? With the big circle, here's our diameter. This is how that works. Not every circle has the same diameter, right? So the bigger the circle gets, the bigger the diameter gets. The smaller the circle gets, the smaller the diameter gets. That's why it works for every single circle. When I was in school, basically the teacher said, here's your formulas, make them work, right? And I always sat there and I was like, what in the world does pi mean? Where do they get this number? Why are they just throwing this at us out of nowhere? Pi belongs on the dinner table, not in the math classroom, right?
Oh no.
Well, this is why they do this. A bunch of people way smarter than me figured out that for every circle you have this in the circumference, there's pi amount of diameters. Alright? So, do we all have this written in our flip books?
Yes.
Yeah? Alright.
Hurry up.
I have another formula for you. It's the area of a square. Or of a
what?
circle. Area of a circle. I'm sorry.
Seriously, anything round
Like that? Like this, Mr.?
Clear this out for me.
Alright.
Get rid of it.
Make it go away.
Gather round, class.
Class.
So Mr.
Oh, I know. That's what they're doing.
Oh, you broke it.
Everyone agrees it was Jocelyn, right?
Yes.
All right. Didn't know that was okay. There we go. We'll use the paper plate.
Yeah. Big plate.
This group, come over here. All right. I want to show you guys something pretty cool.
Quit poking each other like little kids.
You took my salad.
Yeah, you can move your chairs. You don't have to stand up. You can come sit around there. Yes, Joel.
You can Hoover Dip it over there.
Do I have a script?
Yes, you do. All right. Can everyone see the circle?
Yeah.
If I put a radius in this circle right now, does it matter which direction I go?
No.
I can go this way. I can go down.
Clock.
I can go up. I can go to the left.
Well, it does kind of. Like,
Jocelyn made a very good point. It looks
You
kind of
can't-
like a clock, right?
you can't go out like diagonally.
You can. I disagree. I think you can. As long as it touches this midpoint and comes to the edge of the radius. But look at our formula. What's it say? Everyone go.
Pi RT.
A equals 3.14 to the second power.
3.14 for pi.
Yeah.
So
Time.
r squared.
Oh yeah.
What's a squared number?
Like 6.
6 squared is like 6 times 6, right?
Yeah.
3 squared is 3 times 3. What's r squared?
R times R.
R times r. So if I have this radius that goes out to the right and a radius that goes up top, I can make a square based off of r times r is r squared, right? So I can come out here and then I can connect this to create a square, right?
Oh, it's a square.
That's really cool.
And now we have 4 squares, right?
I think you just blew my
Pick
mind
up
again.
plate.
I blew your mind again? Here,
How many times can that happen in
here's
one day?
1r squared, 2r squared, 3r squared, and 4r squared. But the circle doesn't fill all of these r squareds, does it? We have this little area here, for instance, that the circle's not inside of, right? So, if we just want to take a look at this square here, what percentage of that top square, well for you guys it might be the bottom square, but what percentage of that square is occupied by circle? Just talk, you 4 talk together, you 3 talk together, and come up with a percentage, alright?
Wait, what's the question?
What percentage of this square has a circle? Here's half of it,
I
so it's
said
going to be
25.
Yo, he just snorted. Alright. I say 4
I say
feet.
25%.
You said 3/4?
Or 25. 1/4.
Oh, are you talking about this piece or this piece?
That piece,
This piece is what? So you're going to say this piece is about 3/4?
75.
Alright, what did you got? This group says 75%. What does this group say? This square right here. What percentage has circle? About 75. You guys agree to it? Alright, so you guys have said this number is 75. That doesn't. So this piece right here. Of this
And how
square.
much is in there?
This piece of the circle covers how much of this square? This group said about 75%. You guys agree with that?
No.
Alright.
How do you... Can you explain it to me? How do you get 75? Because wouldn't each square be like 25?
Why'd you agree with me?
Oh, no, we're looking at this square as just one whole square, right? And you have something that looks a little bit like this, right? So this is half of this square, right? So that's 50%, and we're beyond that.
Oh, I see.
Jocelyn says about 75, because another half of that would be about there.
Oh, you're looking at each square by itself.
Each square by itself is a whole square, right? So, Joel, if I have 75% of this square, what is that as a decimal?
That would be a decimal,
Oh,
but like point.
anyone have 0.75? Alright. You have about 0.75. I look at this and I say, nah, we have about 0.8. It's all a perspective thing, right? Well, how many of those squares do we have?
It's 4.
4?
Yep.
Alright, Quincy, get on the calculator. Daddy, get on the calculator. Alright, you do 0.75 times 4, you do 0.8 times 4, alright? I don't think that one's going to work for you.
0.7 what?
0.75 times 4.
Okay. I got 3.
Quincy gets 3, and Daddy's getting 3.2. Alright.
Wait, you said 0.8 times 4, right?
Yeah. Yep.
Alright, yeah.
So if Quincy gets 3 and Daddy gets 3.2, do we have a number that falls in that range?
1 is.
Look at that formula up there. Is there a number in that formula that falls around 3.2, 3-ish up there?
Yeah.
What?
The 2 right there.
The 2? That's a square.
Or
What's pi again?
3.14. Oh.
3.14.
4.
Oh my goodness.
Oh, that's
We can't blow people's minds 3 times in one class, can we?
Oh my gosh.
We could.
It's a possibility.
Too
You
much.
just broke the record.
So, if this circle is in here about 0.75 times, it's in this one about 0.75 times, 0.75, 0.75, right? And when we multiply that out, we got about 3. I said it's about 0.8, we got about 3.2. Again, a bunch of people much smarter than me found out that this area formula works because how many r squareds make up the area? Pi amount of r squareds. Alright? So you might want to write your area formula in there for that, alright?
What part of the flip book should we put it at?
I would put it in the same, oh, you already put it in there. A equals, did you get the circumference formula?
Oh.
C equals pi d. So while I was doing a little bit of research on this, I came across this website, and I thought it was the coolest thing ever. Because it gives you a really good visual as to how we deal with radius and diameter, circumference and area and stuff, right? Yeah, I know, right? Who would do that?
You.
Only a student teacher.
We're Johnson.
Hey.
Oh yeah, that's right, it's Jocelyn, I'm blaming it on Jocelyn.
Just gonna blame it on me.
I forgot about that. Alright, so if we look up at this board, here's a circle, right?
Yeah.
We can move it however we want to move
Whoa.
it. We'll make it a little bit bigger.
Bigger.
And it's showing us that our diameter is 9.77 and our circumference is 30.73. So what they did is they took a little piece of this diameter and they did the same thing you guys did. Here's 1, here's 2, here's 3, and then that little red piece is just that little bit extra. If you watch them take it apart, there it is.
Whoa.
You want a replay there? There you go. And that's how you realize that it's pi amount of times, okay? So, if you all would do me a favor, go ahead and grab y'all's journals. Y'all's. We're in the south. Oh, here they go. There you are, alright? There, that's it. Cody.
Yeah, it's a thing.
Yes, sir.
Yes, sir.
I'm sure we had those.
Mr. Daddy. Jolly Oxen.
Yeah, mine is like.
Ethan. Ethan, right?
Oh, I don't have.
Hands out, girl.
And Dominic.
Can I have Ethan?
Huh? He's been
Is that his?
smart.
Thank you, sir. Nah, this is.
Alright.
Yeah, mine.
Go ahead and open up your journal.
Sorry.
And what I want you to do is create a table that looks a little something like this, alright?
That's a lot of work.
You only need one, we only need one grouping, alright? So you're going to do the RDCA across the top and then put one little area for you to fill in answers, okay?
Alright.
So make a circle.
No, you don't have to make the circle, just make the chart. Put an R, D, C, and an A across the top.
Can we put like dots in the? Mr. Cook, can we like put dots in the chart so we can go ahead and?
Oh, I'm gonna tell you what to put in the chart, alright? Everyone have their chart?
Yep.
Alright, here's what I want you to do. Pick one area. You can pick the radius, the diameter, the circumference, or the area. And just put whatever number you'd like in there. Alright?
6, 5, 2, 1.
Make it a reasonable number, because we're gonna have to do operations with this number. Alright?
Would it be easier if you had like a low number?
It would be easier.
Okay. Wait, what do we put in where?
You can put whatever number's in your head right now, put it under one of those tabs. Alright?
That's what I put.
Oh. Where the group of one? What'd you put in?
There's a random number in one of these boxes. Joe, put a random number in one of these boxes. Put
I think 5.
Alright. Well, I know what you're up to. Where's my
So 4,
Over there.
6.
I'll put it over here. Our skateboards tend to run away.
Oh.
Oh,
So for what I got.
you're not doing your own work. You just did your work. Alright, once you fill in one of these boxes,
People are so kids.
just
One.
She picked one.
what's our relationship between radius and diameter? Someone help me out.
Radius and diameter have a relation by
So if I have a radius here, if my arm is 5 feet long, what's my diameter?
10
How'd you get that?
feet long,
Divide.
cause you stretch.
So our diameter is twice as long as our radius?
You times it
So
by
you
Alright.
times it by 2.
If we have a diameter of, like you said, 10, what's our circumference going to be? What's our formula tell us to do?
Times it. Or divide it.
So
What's the formula for the circumference of the
pi
circle?
diameter.
Pi diameter. So what am I going to do with this diameter?
Times it.
Times by
Times
3.1.
3.14.
3.14. Okay. Area. What's our area formula?
Pi r.
pi r2.
Pi r squared.
radius.
So if you have a radius, how do you figure out the area? You're going to do what to this radius?
Is it okay if I use the radius?
Yes. We're going to square this radius, right? And then multiply it by pi. So each one of you has just filled in one blank in your chart. What you're going to do is you're going to pass your notebook to the left. Whoever you pass it to is then going to use the number that you filled in and fill out the rest of that chart. All right? Yeah, see, I told you weren't doing your own work. You just did all this stuff for nothing.
Get the thing. You're an idiot.
All right, did everyone switch?
Yeah, this is yours.
Thank you, sir.
Lefty, y'all. Yeah, you are my left.
Math has to do with it.
Absolutely. That's why I love it.
Left is this hand.
Mine's right there. Remember,
I'm not a
All right, go ahead and switch.
put a number in there. Whatever number you want.
That's right.
Any number.
And then
Makes you feel better.
I just gave you a cheat sheet, you guys. So you know how to find diameter.
So you do mine.
So area.
Boy, who do you want to do?
Just switch. Okay.
So what what area is
So would it be like?
The radius is 3. What's the diameter?
radius?
I'm sorry. I know.
Diameter,
It's gotta be
circumference, and
Alright.
something like.
So times 1 times 3.4. 1.4.
3.14
This is
times.
for you to show me what you've learned today, okay? I know. I did not realize it was glued
I
into the
get
wall.
it.
I saw the corner of the screen.
Radius diameter,
Oh my gosh, you learned a lot.
Circumference and area.
and area. I knew that.
Wait, so what's
Nine.
And then 9 times the radius of what?
3 point.
No,
No.
you times it by 3.14.
So we
That was just
Radius. Think about the beginning. Radius.
14.
What's the diameter?
Here's my radius of 1. What's my diameter?
I'll have a calculator.
duh.
And for what I would have, so you got times your radius by 3.
Let's see.
Circumference.
You got times the radius by 3, and then
Kill me, sir.
That would be.
and then you get that answer, and then times it by 3.14.
Ew.
Hi, how are you?
My hand's all the way over here.
So,
What you got for the answer?
you're observing this gentleman.
Yeah.
And so I'm sorry. I wanted to show, I wanted him to show us an incredibly average.
So the circumference would be.
What would D be? Stop.
Answer.
Every game that you ever had.
Wait, so circumference is all the way like across. Oh, all the way around. Okay. Oh, so it'd be 3. Okay.
Yep, you're getting there.
What is the
So you times 3.14 to.
How do you get there?
Okay.
What is the? What is the?
This Davis.
2, you idiot! You would love to sit
You just
around.
got that on camera. What would C be?
So that's what we
I can't tell you.
So I multiply by 3.14.
I was a little bit
Oh,
early.
is there 5 on there?
Alright, once you're done that, put your notebooks back.
Yes, it's 1, 2. If all the way is around, it's 3.14. And then you multiply 3.14 to the R number. Oh wait, it's 3.14. It ain't gonna be 1.
1, 2, 1, 3.14.
Yes!
You're the nicest person ever, but I can't give you a
Boy!
Good? We all set?
Yeah, here's your pencil bag.
Alright.
Here you go.
Where's that
I
stack?
got all my hats.
Boy, you ain't
Yeah, I hope you
Now, here's your exit ticket,
I
alright?
still think you should. Do we need these?
Exit ticket. There we go. Here's what I want you to do.
Oh,
Here's our LEQs. Pick one of those LEQs, answer it for me. That's your exit ticket. Derived means how did they come up with it? Alright? Tell me in your own words what that means to you, how
what
they
does
came
the
up
first one mean?
that circumference formula, that C equals pi d. How'd they come up with that? Tell me in your own words how they came up with that. Alright? If you want to do the area one, tell me how these big smart math guys came up with the area formula.
They went to
It's
school.
what we did with that string. Huh? Exactly.
Wait, how'd they get 3.14?
Yeah, how do you get 3.14?
How did they get that whole formula? How'd they come up with that? What did we do with our string? We did it earlier. We discovered something.
Put it straight. And then you mark.
Go ahead and write it down. Come here. What is... Which one do you want to do? First or second? Derived means how they come up with it. When you finish writing your answer, hand it over to me. Go ahead and answer one of these questions. Alright? Same for you. Answer one of these questions. Alright?
There you go. I hope I answered. Can you follow my folder? Here you go. And here you go.
Find it.
Do we need these?
Where's the bucket? Oh, can I put it up here?
We all
I don't know how they did it.
Good job today, guys.
Woo, they did good.
your hard work. I heard you last night. Yeah, you were.
See you on Tuesday.
Wait, really?
Yeah, we're off on Monday.
No, but we have 318 next week, don't we?
I'm gonna make 2 copies of this.